So today I'm going to go over Wye Auto tap transformer calculations. Okay, so what I've written in black are the given values here for this question. So we have a 600 volt supply at 100% tap, and then we have a motor, a 50 kVA motor at 80% tap. So first of all, what we're going to find first is the primary line current right here. So we're going to use our three-phase formula for this one. So we have to start off with 50 kVA. This is because of the transformer rule, kVA in equals kVA out. So it'll be 50 kVA on the primary side and on the secondary side over here. So we have 50 kVA over root 3 times 600 volts. We use root 3 because we're finding a line value. If we're finding a phase value, we will just use 3 here. Okay, so it's 50 kVA over root 3 times 600 volts. That gives us a line current of 48.11 amps on the primary side. Okay, so we've got this value here. Okay, so now we can move on to the secondary side now. So first, what we have to do on the secondary side is find our line voltage, okay? So what our line voltage is going to be 80% of our line voltage on the primary side, which is 600 volts. And we use 80% because we're on the 80% tap. So 600 volt times 80% is 480 volts right here. Okay, so after that, we can find our line current. So our line current on the secondary side will be it'll actually increase from our primary side. And that's because since our voltage decreased on the secondary side, our current has to increase to maintain 50 kVA, right? Because if they both decrease, it would actually be less than 50 kVA. But because it's a transformer, it has to be kVA in, kVA out. They both have to be equal. Okay, so we do the opposite of our voltage. Instead of multiplying it, we subtract it from our primary side. So our primary side line current was 48.11 amps. So 48.11 amps divided by 80%, and then we get 60.14 amps. And that's our line current on our secondary side. There's also another way to do this up here. It's just a longer method. Maybe it can help you understand this better. But what I did here is to find line current on the secondary side, I take 600 volts times divided by root 3 to find our phase voltage. So that's going to be right here. This is our phase voltage across the windings right here. It's also coil voltage too. So that's going to be 347 for our phase voltage, right? We have here. After we get our phase voltage, we do 347 times 80% right here because we're on the 80% tap. So 80% of 347 is 277 right here. So this is going to be 80% of 347. Okay? And then we're trying to find our line current on the secondary side here, right? So then we're going to have to multiply 277 by root 3, and we get 480 volts. And then for our current on the lines, our line current on the secondary side, we use 50 kVA because of the transformer rule. kVA has to be equal on each side. So 50 kVA, and then we do divided by root 3 because we're finding a line value times the line voltage on the secondary side, which we found right here, is 480 volts, and we get 60.14 amps. So you pretty much just get the same answer. It's just a longer way of doing it. Okay, once you've got your values for your voltage and current for the primary and secondary side. You can also find your common right here. This is the common winding right here, and it's pretty simple. The common voltage rate is right here is 277 because it's 80% of 347. And then our current on the common winding is going to be the current on the secondary subtracted by the current on the primary, and you're left with 12.08 amps. And this is how current is flowing. So you have 48.11 amps coming through here, and we have 12.08 amps here, and then they add up to 60.14 amps. So it makes sense. And then if you had your load on this side, so that if the motor was on this side and your supply was coming this side, the calculations would be the same, except current would be flowing this direction, and then it would just be splitting up like this. So it would be going up through here and then down through the common here. So you'd be losing current here and here. So it would just be like splitting instead of adding up, because then what we have right here is they're just like combining together. But yeah, that's pretty much it. These are very similar to the open delta auto transformer. They're just slightly more complicated, but yeah, that's pretty much it.